Alright, so this is day 2 of the build, and essentially what I've done is I've placed all my parts together just to kind of figure out where exactly I want them. You're going to see the use of a lot of like zip ties, and that's kind of hold the stuff in place. So there's essentially like this German tank chassis that I have, and in the end I want to have it run these gear motors, and I want that to do it off of software. So what I have here is I have my Pi, I have that cigarette lighter phone charger that I'm giving essentially the 11 to 12 volts to, which is creating 5 volts for my Pi to run off of. And while Pi itself can run servos, I bought this servo hat, which allows me to run 16 channels, but it also requires its own 5 volts. So these two wires right here are bleeding off 5 volts to power the hat. And let me show you the setup here. Essentially what I have is the infrared camera. I just have this test servo because eventually this is going to be connected to like an electronic speed controller, and I'm going to have 2 speed controllers. They're coming in the mail, and they're going to run these motors independently. So I'm going to have them on channel 0 and channel 1, and then I can add servos later on if I want. So the setup I have right here is I've got twin 11.1 volt LiPo batteries that are currently powering this phone charger that I've gutted, bringing it down to 5 volts, so it's powering the servo hat, and it's powering the Pi. And eventually I'm going to have them connected in parallel, so that I'll have 10 amps of power all together. So right now it's been running my Pi for maybe an hour as I've been walking through some code and installing the drivers for the Adafruit 16 channel servo hat. And I just wanted to share a quick success. So the example code from Adafruit is supposed to take whatever is on your very first servo channel and run it all the way to the left and run it all the way to the right. So here I am in Python 3, and I'm going to hit F5, and it's going to start the code up, and you can see that is currently running the servo left and right. So I'll terminate that. And in the future, what I want is to be able to have this thing kind of run on its own. So it's got a GPS module, so it knows where it's at. I'm also going to install some ultrasonics on the front so it can know when it's up against an obstacle. I bought a kit for like 30 bucks. And it comes with all sorts of parts and pieces. Super worth it. And it's also got like an accelerometer, so I'll be able to attach a servo, or not a servo, but a sensor, to be able to tell how what G-force it is, if it's upside down, that type of bit. So, and Pi will run the camera. I might have it put up some variables so it doesn't go outside of like a fence coordinate that I put up for GPS, and have it turn around and just kind of randomly take pictures and log where it's run into things, and avoid those obstacles in the future. So that's day 2. Day 3, once I get the electronic speed controllers, I will be able to attach that from the servo hat to the motors. Essentially they're like a variable resistor. They attach your main battery power to your motors, but it only like gives a certain amount of energy to your motors depending on what your servo controller is telling it to do. And that's kind of how, in very simplistic terms, how an electronic speed control works. So once I get those attached, software-wise, I should be able to start writing code and giving it logic cases like, you know, if you see something in front of you, back up and turn right and try again. That type of thing. So anyway, that's day 2. Just wanted to share. Success! I'm really happy. I'm an amateur Pi builder, and I guess I'm worried that I might be biting off more than I can chew, but here we go. I'm in it for the long haul.